to the session. I'm proud to welcome to the stage Marc Linster, who has had a long and industrial and a long and illustrious, I meant to say, career. Most recently at EDB, now independent, and he will be talking to us about something not many people mention, because we tend to talk in terms of rapidly changing data and databases. Marc is going to tell us the opposite. What if your data slowly changes over time? So please, a warm round of applause for Marc.
All right. Thank you. Thank you, everybody. So this talk, it may be to those that are really versed in it, like Chris that we heard earlier in the same place, may seem like, yeah, we understand how this works. But it goes back to a frustration that I had many years ago when I was working with PeopleSoft, which was implemented on Oracle, and had a particular way of modeling how prices would change over time. And it was like really hard to figure out, okay, on Tuesday, the 4th of October, 22, what was the price of a given thing? You had to write a lot of code. It always bugged me, okay? So more in general, now that I'm teaching Postgres and I'm working with other Postgres companies, I'm thinking more about, okay, how do we model things right, or as good as we can from the beginning on, to avoid performance problems. We're spending a lot of time here talking about, tuning and making things faster, etc. I believe any problem that we can avoid or just make go away, that's just a much better way of dealing with problems. So data modeling has been a passion of mine for a long time, and slowly changing dimensions is something that I don't think we speak about often enough, because we have so many data elements that are changing over time, and there are some pretty good tools for how to handle it. Now, before I dive into how they work and what they are, I also want to say this is somewhat comparable to work that Henrietta has been pushing for bitemporal data representations, but that is even more advanced. Slowly changing dimensions, as they were introduced by Kimball in about 2000, are really used to express that our knowledge about a data element, let's say a price or so, that the price is changing over time, or that the bill of materials is changing over time, or a reporting relationship is changing over time. Bitemporal data adds another dimension. It doesn't just say from when to when was what valid, but also when did we learn about this validity. So it goes a lot further. Slowly changing dimensions just tackle the first problem. You may say, hey, but that's trivial, or just make a table where we record what happened. Well, there are multiple ways of doing that, and they all have advantages and disadvantages. And that's what I wanted to explore here a little bit. And as always, it depends on what we're trying to do. What are we trying to figure out? Like, are they questions like, when was the change effective? From when to when was it valid? So what are really the things that we would like to figure out? Okay? And again, credit to Ralph Kimball. He introduced this in about 2000, more on the data warehousing side. But I believe today, in, for example, e-commerce systems, where we're modeling prices not just in the past, but also going forward, right? How many of you have staged content and knew that, hey, tomorrow price changes go into effect. Tomorrow we're going to launch new products. Well, that's a good use case, in my view, for slowly changing dimensions. It's not just about the past. It's also about the future. Okay? So they defined 6 types of slowly changing dimensions. Okay? The very first one, type 1, is really just a correction. You don't actually record, except in the log, when the change was made, because all you had was a typo in a description or a typo in a price. So that's SCD type 1. You only have one table with the correct data. Type 2, you add a new row for every change, and you record start and end date. Okay? But that's all you do in there. In type 3, you track the date of the last change and the prior value. So you can't really go look back in history a long time, but you know when the thing changed and from what to what it changed. It's very simple. Okay? Type 4 has a new row for every change with a validity date. Okay? Type 5 then takes type 4 and type 1, that's why it's called type 5, and combines both of these approaches. So you have a table with current values, and you have a table with historical values. Okay? And you may think, hey, that's pretty good, that works. Well, except if your values are not numbers, if they're a composite data type, let's say like a bill of materials. Now suddenly your transaction that referred to the current value, right, now needs to refer to somewhere else. So if you use that approach, there are significant challenges with it when your data becomes a little bit more complex. And then there's type 6, which is really a combination of 1, 2, and 3. And it combines everything into a single table where data elements have a start time and an end time, or a start date, end date. And there's a marker for what is the current value. And you can already start seeing that there's some really interesting capabilities there with type 6. And type 6 is the one that I think is in many situations the one that I would use more. Okay. So we're back to our problem here. Hopefully I will be able to get the system to work with me again. Okay, good. Thank you. Thank you, Jimmy. Okay, so I'm going to spend most of my time talking about type 6 because I think that is the most interesting and the most elegant way. And the reason why I'm doing this presentation here is because I had to work with Oracle before, and maybe it was my lack of Oracle, that could very well be, my lack of knowledge of Oracle, okay? But when I started getting into Postgres, I saw that Postgres has some really, really nifty ways of dealing with this type of complexity. And they're really things like date ranges, and combinations of B-tree and gist indexes to tell you why I think this is so cool. Okay? So let me quickly go through this. I already said type 2 is each change gets a new row. And you may think hey, that's pretty cool. I just have a primary key that is my combination of, in this case here, my product ID, my start date, and my end date. That's my primary key. That's how I find everything. Well, not if you have prices in this case, for example, that were valid when you started the system, or that stay valid as long as you want to, because when you use null in the primary key, you can't do that. Okay? So that doesn't work. Big disadvantage in my view. Okay? Type 3, you have an extra column and you just kind of record the prior date. I don't know. It doesn't tell you much. In fast-moving times, you can't really find out how things evolved. Type 4, okay, now you have an effective date, and that's what I saw in PeopleSoft, and it's a pain in the neck, okay? Because if you want to find out what the price, for example, was on a given date, you have to find the last change, and then you have to make sure that you're between the last change and the next change, okay? So lots of coding, not very elegant. From a performance perspective, really problematic, okay? Type 5, you have a history table and your base table, okay? And that works actually quite nicely. If let's say you have a sales transaction, and that sales transaction, as Frank Pajot said yesterday, you copy the price into the sales transaction, then it works. If the reference in the sales transaction, for example, just says, get me the price of the product, then it doesn't work. Because over time, the actual price of the product at that point in time slides into the history table. That's not so much of a problem with a base data type, because copying it is not that expensive. But if you had more complex data, let's say like a bill of materials, this would be prohibitively expensive and really problematic, and you'd have to go bend all your pointers as soon as something moves into history. So really a problem. Type 6, the one that I like best, okay? And that really is, you see, you have a start date and an end date, But the really big thing is you have a current flag. So now your system can use an index on current, and you can actually easily imagine a covering index. Okay? So now you can answer the question about the current price of a product by just doing an index lookup. You don't actually need the history, but all the trend, all the data is in there, and you don't need to bend any pointers. So pros and cons, I already talked about them. I think type 6 is the most elegant one. Interesting is you could also add partitioning to that. So if you want to move older prices to an archive partition, you could do that. You could do that by just using the end date of the price, for example, in that case, as a definition for the partition. So it's a very interesting thing. Now, there's a lot of problems that people perceive with slowly changing dimensions. They say it's hard to do. Defining ranges from when to when. Managing the boundaries between ranges, right? Finding out what was the value on a given day. And avoiding overlaps between ranges. Okay? If you do this, and that's how I did it, but again, Oracle may be able to do it, and I just didn't know how. But if you do this without really digging into it, this is hard. Because now you need to put semantics into the code, for example, to say, is the beginning or the end of the range included or excluded? Okay? How do I find out if something was within the range? Yeah, you can write some SQL with that, but it's a lot of SQL that you need to write. And you need several indexes to be able to do the whole thing. Now, what really excites me is what Postgres gives us there. Date ranges. I think it's a cool data type that I don't see used enough. That allows you to do things in like one line. Okay? One operator. That is like, really use it. Okay? It's a built-in data type. It's fast. It's easy to index. Okay? Not with a B tree. But it's easy to index with a gist. Okay? Managing the boundaries. Again, Postgres does that for you out of the box. It's the square bracket and the round bracket. Square includes, round excludes. Easy. Okay? What was the value on a given day? Well, again, there's an operator. There's the operator here that says, okay, was it included? You just say, is that date included in that validity range? One line, one operator. Okay? And the last thing here is what I think is the coolest. Okay? I can just write one constraint that makes sure that no product can have two prices that are valid on the same day. Right? I mean, it's an extension. You have to know it exists. You have to load it. But that's all you need to do. Okay? And that's really where my excitement comes from. I use this as a teaching example to show folks that, hey, it's actually worth reading the manual. Just because you learned about SQL doesn't mean you know how to use Postgres properly. Those are cool tricks that, you know, if you tried to do this in SQL without date ranges, without B-tree gist, that'd be a lot of code that you'd have to write. And even worse, imagine a developer would try to reproduce that code wherever there's an insert into that table. Okay? It'd be horrific. At least in my view, it would be. Okay? All right? So that's really where my excitement about Postgres comes from and why I think this is a pretty good example to allow people to understand that you know, really dig into the features. It's similar to the things that Chris talked about before here, you know, an hour or 2 hours ago. If you use SQL right, you can eliminate a tremendous amount of code. And just like Chris, I'm lazy. The less work I need to do, the more somebody else does for me, the better it is. Okay? So the innovation here is use date range or any range types, right? They're all pretty cool. And then the use of this extension, the B-tree gist, to solve the other problems, right? In this little blog thingy there, I'm also showing how you can then use window functions to automatically find any gaps in the pricing. Okay, that's 6 lines of code. Okay, maybe that's a little much, but with 6 lines of code, you can find gaps in the pricing. And the database makes sure that you have no overlaps and no conflicts. So for me, that's, that's pretty cool. That's why I think, do this makes life a lot easier. So, questions? Devon, there's a question, the guy in the red T-shirt, to your right, second row.
Thank you. I've worked on a similar system with basically also temporal data. What we used instead of null values in the until column and a flag for current value is just choose a very large end date as the default, and then you can use only those 2 columns, and you are not dealing with nulls, which in my opinion are the worst invention until the invention of the social media. So yeah.
Yeah, I think that is definitely an option. So for everybody to understand, because you can't use null in a column that is part of a primary key, there's certain things you cannot do, right? And then you would need to use a surrogate key. But this workaround where you use a very, very large date in the future or a very large date in the past to say and arrange that started or ends really late is absolutely a workable way, yes.
In traditional coding, you call that a sentinel value.
Yeah, okay. Thank you.
Actually, I wanted to ask the same question because Postgres has unique option of using infinity.
Okay.
Which I use for bitemporal, and then it's greater than anything, and you can use something within this interval, which is until infinity, and also you can use partial index where upper boundary equals infinity, which works.
Okay, I will add that to the example. Thank you.
Also addition. Yesterday, Gulchin gave presentation about new things in Postgres 18, and you don't even need to do extension because you can generate now primary keys with ID and data range. Because
that's true. I saw that too. Yes. Yeah. That's.
So for details, go see other presentation.
Yeah. Good. Thank you.
Thank you.
You make me run. Lose weight.
Hello. So I have a question about partitioning. If you have this kind of a table with a date range or with the 2 columns, how would you partition it?
I would try to partition it by the end date of the validity, right? If you want to do that partitioning. So that basically you could say, okay, I have dates from the last year, everything that was valid till the end of last year, and then I can truncate that. Or drop it, okay?
Any other questions?
So on your previous slide, number 4, you said an extension B-tree gist was necessary. What is it about B-tree gist that makes it necessary versus just ordinary gist?
Oh, because it combines both the equal and the overlap, okay? So that's like, you're absolutely right, I should have said that. That's the cool thing, okay? For those of you that are digging into it, it doesn't perform, if you use it only for equal, it doesn't perform as well. Apparently, I have not measured that, but that's what the literature says. But you combine those 2, and now you can do this in one statement. That's what I love, so. But the gentleman up there is right, and I'll look that up. If you can do that now without even adding the extension, that's even more better good.
You said you can also use that for values in the future, but then the assumption that the latest end date is the current value is not true anymore. And it changes as time progresses, so
that's correct.
At some point,
yeah,
an entry becomes the current one.
This is the problem that you then need to solve, is this current flag, okay? This current flag cannot be like a generated column or something like that. You actually have to either on an after update trigger recalculate that current flag, or use a cron job or something like that, right? You cannot. There's no way to derive this automatically.
Okay.
Okay.
Okay, I have another solution for future. To find current value, if you have future values, you just need to put condition current timestamp is inside the range. That's it. It's still very easy and efficient.
Yeah, you could. Current timestamp is inside the range. Yeah, the problem is if you try to do that with either a covering index, or in this example here, we're also using that for logical replication, then it would need to recalculate that index, but there's nothing that triggers the recalculation, right? Or in the logical replication, it's the same thing. The logical replication can only refer to mutable functions, and now or current time is not mutable. So, thank you.
I also want to mention there is two issues with such design. First one is probably better to add a check what if current is true and date should be null, and not opposite way, because it's possible to break it. And also, I think it's better to create a unique index with expression on product ID with expression where current is true, to ensure you have one current for a product ID.
Yes, yeah, absolutely. There should only be one current, that is true, yes.
Great. I think that's all the time we have for questions. Thank you very much, Mark. If you have more questions, go look up his blog post or speak to him outside.
Thank you.
Thank you very much.
Thanks, Jimmy. Thank you.